Hey everybody, this is Joey, the resident math guy at Thinque Prep, and in this video we'll be going over free response question number 6 on the 2019 AP Calculus AB exam. Here we go. Question 6 goes, functions f, g, and h are twice differentiable functions with g of 2 equal to h of 2 is equal to 4. We're given this line here, and it says that this line is tangent to both the graphs of g and the graph of h, both when x is equal to 2. And part A just asks us to find the derivative of h when x is equal to 2. And what does that mean? Well, the derivative of h is basically the slope of the tangent line when x is equal to 2. Well, they give us a tangent line. And if we look at this coefficient right there, 2/3, is the slope. So that's all you need to do for part A. Just say h prime of 2 is equal to 2/3. In part B, we're given a as a function here is 3x cubed times h of x, and then we're told to find a derivative of a, and then we're told to plug in 2 and we're done. So the tricky part with the first part is we have a product rule that we need to do here. So we have this is our first function, this is our second function. So if we want to find a prime of x, let's just follow the product rule. We have first times the derivative of the second, h prime of x, plus the second function, which is h of x, times the derivative of the first. The derivative of 3x cubed is 9x squared. And then you can just go ahead and leave it like this. And then we need to plug in the number 2. When we plug in the number 2, we get 3 times 2 cubed times h prime of 2, and then h of 2 times 9 times 2 squared. And then from part A, we found that h prime of 2 was equal to 2/3 because that's the slope of the tangent line. 2 cubed is 8. If you got the wrong answer for part A, you'll still get credit if you bring down that number from part A. And then according to the question, h of 2 is equal to 4, so we can replace that there. And then 9 times 4 is 36. And at this point, you do not need to do any more arithmetic according to the AP Calculus grading standards. However, if you want to go ahead and do it, the number is 160. Just be aware that if you do the arithmetic and get it wrong, you won't get the point for this question. So part C is going to be a doozy. We're given this gnarly looking function for h. And then it says it's known that the limit as x approaches 2 of h of x can be evaluated using L'Hospital's rule, or if you want to say it properly in French, it's l'hôpital. You can say hospital though, I don't care. And then we're told to use the limit definition to find what f of 2 and f prime of 2 is, and show the work that leads to your answers. Well, if we look at the opening of the question, it says h is twice differentiable with h of 2 is equal to 4. Then because the function is differentiable and continuous, we should be expecting the limit as x approaches 2 of h of x to equal 4. However, since we have this rational function, since we have to use L'Hopital's rule, we're probably going to get the indeterminate form. We have two indeterminate forms for rational expressions. One is 0 over 0, one is infinity over infinity. Let's evaluate the limit to see which one we get. So the limit as x approaches 2 of h of x is equal to 2 squared minus 4. We're doing direct substitution. And look at that. The top is approaching 0, right? So then we can safely assume that the bottom is approaching 0 as well. So then how do we show our work? We can say something along the lines of limit as x approaches 2 of x squared minus 4 is equal to 0. Therefore, the limit as x approaches 2 of 1 minus f of x quantity cubed is also equal to 0. So then if we go ahead and solve this, we get that f of 2 is equal to 1. All right, so now we can use L'Hopital's rule here. And then remember that when we're evaluating the limit, if we get indeterminate form, then we just need to take the derivative of the top and then divide it by the derivative of the bottom. Well, the derivative of the bottom, the 1 goes to a 0, so we get negative 3 f of x squared. That's the power rule. And please do not forget the chain rule. The chain rule says we need to multiply by the derivative of what's on the inside of the function. Now let's go ahead and do direct substitution to see what happens here. We get 2 times 2. So we don't get 0 on the top anymore. So we know that this should give us an actual number, and that number should equal 4. So what does that tell us about the bottom? The bottom of our function should equal 1. Right? Because 4, if we want to be redundant, can be written as 4 over 1. So we can say something along the lines of the limit as x approaches 2 of negative 3 times f of x squared times f prime of x should equal 1. And let's go ahead and do some direct substitution then. So negative 3 times f prime of 2 squared times f prime of 2 is equal to 1. Well, f of 2 is equal to 1. And then this 3 is over here, so we can just say f prime of 2 is equal to negative 1 over 3. And that's your complete answer. And if you write out all the stuff like this, that should be enough work to show the reader that you know what you're doing. So part D says, it is known that g of x is less than h of x for this interval here, 1 to 3. And then we're given this new function k, such that k is trapped between g of x and h of x for that same interval. And we're to show if k is continuous at x is equal to 2, and we need to justify our answer. How do we show continuity? This is all the way back to chapter 1 of calculus. To show continuity, we need to show that the limit as x approaches 2 of that function is equal to the value of that function when we plug in our x value. Well, let's show the left-hand side first. Since we have this three-way inequality here, we can show through squeeze theorem what the limit of k of x is. So let's show the limit of g of x is equal to the limit of h of x. Well, how do we know the limit of g and h? Well, the question says that f, g, and h are twice differentiable functions. And you need to remember that if a function is differentiable, it is therefore continuous. If these two functions are continuous, that means the limit as their x's approach 2 also equal 4. So then we can show that the limit as x approaches 2 for k of x is equal to 4 by squeeze theorem. Similarly, if we want to show the value of the function, we're going to use this inequality here again, and we can plug in the number 2. So g of 2 is less than k of 2 is less than or equal to h of 2. And the question itself tells us that the value of the function of both functions are equal to 4. Therefore, we can say k of 2 is equal to 4. How should we type this up then if we want an explanation? Well, I'd say something like this. Because g of x and h of x are continuous, well, let's say differentiable first, are differentiable functions, then they must also be continuous functions. By squeeze theorem, we know that the limit of k of x as x approaches 2 must equal 4 because the limits of g of x and h of x as x approaches 2 equals 4. Furthermore, because g of 2 is less than or equal to, obviously you'd write it the proper way, it's less than or equal to h of 2, k of 2 equals 4. Therefore, k of x must be continuous when x is equal to 2. I think some sort of explanation like that would get you the point for justification. Thanks for watching this video. If you have any questions, feel free to leave us a comment below. Otherwise, if you like this video, give us a thumbs up or subscribe to our channel.